In this lesson, we want to review applications of linear systems. All right, so over the course of the last few lessons, we've kind of talked about systems of linear equations in 2 and 3 variables. Now we're just going to look at some kind of application problems or some word problems that come up in this section. And then from here, we're just going to be dealing with kind of matrices. All right, so let's start out with the first problem. So we have that a health bar is made from a corn mixture, an egg mixture, and a vegetable mixture. 1 ounce of the corn mixture contains 0.25 grams of protein, 0.3 grams of carbohydrates, and 0.4 grams of fat. The egg mixture contains 0.4 grams of protein and 0.2 grams of both carbohydrates and fat. Lastly, the vegetable mixture contains 0.2 grams of protein, 0.1 grams of carbohydrates, and 0.3 grams of fat. How many ounces of each mixture should be used to create a health bar that contains 22 grams of protein, 18 grams of carbohydrates, and 28 grams of fat? So just like any other word problem that we've kind of worked on before, the very first thing you always want to do is figure out what are you being asked to find. A lot of times you'll struggle because you're kind of flopping around through information, you're not specific on what you need to find. So you need to key in on that, and you need to say, okay, I want to find how many ounces of each mixture. Okay, so remember we had the corn mixture, the egg mixture, and the vegetable mixture, and should be used to create a health bar that contains 22 grams of protein, 18 grams of carbohydrates, and 28 grams of fat. Okay, so we have 3 unknowns, right? We need to know, again, how many ounces of the corn mixture we're going to use, how many ounces of the egg mixture we're going to use, and how many ounces of the vegetable mixture we're going to use to kind of create this health bar with these specifications. So let's go ahead and label these 3 as X, Y, and Z. So let's let X be equal to the amount in ounces for the corn mixture. And then we'll say Y can be equal to the amount in ounces for the egg mixture. And just to keep this short, I'm just going to leave mixture off. And then we'll also say then for Z, we're going to say the amount in ounces for the vegetable mixture. So I'm just going to put VEG to kind of abbreviate that. Okay, so the best way to kind of look at this type of problem is with a table. You don't need one, but it definitely helps. So I've already kind of pre-drawn one for us. So I'm going to show you how you can fill out the information here and then get some equations going and get a solution. So the first thing is, let's talk about the different kind of mixtures you have. You have the corn mixture, you have the egg mixture, and you have the vegetable mixture, okay, which I'm going to abbreviate VEG. Then we're given the amounts of protein, carbohydrates, and fat. So I'm just going to put protein, just PRO, carbohydrates, CAR, and then for fat, just FAT. Of course, that spells fat, but for the other ones, they're abbreviated. Okay, then we also want to put in a total here, and this will make sense once we kind of have the information going. So what I can do is I can look up, back in the problem, the statistics for how much protein, carbohydrates, and fat each one of these guys have. I'm just going to fill in my table. So let's go back up. So for the corn, for every ounce, it's got 0.25 grams of protein, 0.3 grams of carbohydrates, 0.4 grams of fat. So we've got 0.25 for protein, 0.3 for carbs, and 0.4 for fat. All right, for the egg mixture, we have 0.4 grams of protein and then 0.2 grams for both carbohydrates and fat. So we've got 0.4 and then 0.2 and then 0.2 again. Then lastly, for our vegetable mixture, we've got 0.2 grams of protein, 0.1 grams of carbohydrates, and 0.3 grams of fat. So we've got 0.2 for the protein, 0.1 for the carbohydrates, and 0.3 for the fat. Now I have a column here for the total, and what I'm going to do here, notice how going across, it's all protein, right? It's the protein for the corn, the eggs, and the vegetable. We want to know what the protein total is going to be from these 3 sources. And again, it's based on the requirement that's given to us when we're building this health bar. If we go back, we see that it needs to be 22 grams of protein, 18 grams of carbohydrates, and 28 grams of fat. So for the total there, for protein, it's going to be 22, right? Just going across. For carbohydrates going across, the total needs to be 18. And for fat going across, the total needs to be 28, okay? So this is how we're going to get our equations, because what we know is that the protein only comes from three sources, right? It comes from corn, eggs, and vegetables. the number of ounces of this corn mixture I use, so that's going to be X times this kind of 0.25, which is the number of grams, okay, of protein per 1 ounce. So this amount here would tell me the amount of protein I'm getting from just the corn, okay? But I need to reach this amount, so I'm going to add to this the amount of protein I get from the egg, so that's 0.4 times Y, okay? Then plus, additionally, the amount of protein I'm getting from the vegetables, so 0.2 times Z. This has to be equal to 22, okay, because that's the only place the protein's coming from. The same thing's going to happen with the carbohydrates and the fat. We can just go across. So I can say that 0.3 times X plus 0.2 times Y plus 0.1 times Z is equal to 18. And I'm going to run out of space here, so let me scroll down. I'm going to cut this off. But remember that the kind of column here is for corn, then this guy is for egg, and this guy is for vegetables. So we're just going to copy. We have 0.4X plus 0.2Y plus 0.3Z equals 28. Okay, so that's all we really need to do. So let's just cut this away from here. We're going to take a fresh sheet, and let's solve this system real quick and get our solution for our problem. Now, you can work with decimals if you want. If you have a calculator, it's fine. A lot of people don't like working with fractions or decimals. So I'm just going to transform this into a kind of decimal-free equation in each case. I'm just going to go ahead and multiply kind of everything by 100. So what I'd have is 25x plus 40y plus 20z equals 2,200. Okay, I just multiplied everything there by 100 so that I could clear all the decimals. Okay, so this one's gone now. And then for this one, I'm going to do multiplying everything by just 10, because that's all you need. So this would be 3x plus 2y plus 1z equals 180. So let's erase that. And then for this one, I only need 10 as well. So I'm going to have 4x plus 2y plus 3z equals 280. Okay, so let's erase this and let's scooch this up. So again, when you work with a linear system with 3 variables and you're not using a matrix, the first thing you want to do is kind of look at these equations. So I'm just going to label this as 1, 2, and 3. You just want to pick 2 of them, and then from the 2, you want to eliminate one of the variables. So if I look at these equations, it looks like it's pretty easy to eliminate the variable y, okay? Because I have 2y here and 2y here. So from 2 and 3, I can really quickly eliminate y by just multiplying one of the equations by -1. And I'm going to start with 1 and 2 and just multiply equation 2 by -20. So I'm going to keep equation 1 as it is. So 25x plus 40y plus 20z. And this equals 2,200. And again, for equation 2, I'm going to multiply both sides by -20. So -20 times 3x would be -60x. -20 times 2y would be -40y. And you see that now I have opposite coefficients on y. The -20 times z is going to be -20z. And this equals -20 times 180 is going to be -3,600. Okay? Now again, for this process to work, you want to have this kind of in the format where all the variable terms are on one side and your constants on the other. That way, when you add the 2 left sides and you set it equal to the 2 right sides, you're adding like terms. So 25x minus 60x is going to be -35x. Then this is going to cancel, and so is this. So this would be equal to, I've got 2,200 minus 3,600, which is -1,400. Okay? So let me erase this information. I don't need it anymore. You could really call this equation 4 if you wanted to. So I could say this is equation 4. -35x is equal to -1,400. So from this, I can just solve for x right away. We kind of got lucky because 2 things dropped out. So I'm going to divide both sides by -35. And I'm going to find that x is equal to 40. Okay. So at this point, I know that x is 40. So let me erase this and just put equation 4 as saying that x is equal to 40. Okay, so that's one of my equations. Now, I can't really do anything with x equals 40 because I still have 2 unknowns. So I'm still going to eliminate the same variable, but it's worth noting that when you have this situation, I can eliminate either z or I can eliminate y, okay, from equation 2 and 3 or from equation 1 and 3. And what that's going to do is it's going to give me a linear system with kind of two variables. I already know that x is 40, so I can immediately just plug in and figure out what y is or what z is, again, based on what I choose to eliminate. What I'm going to do is I'm just going to stay consistent, and I'm going to eliminate y again, and I'm going to do that from 2 and 3. So what I'm going to do is I'm going to multiply equation 2 by -1. So I'm going to have negative 3x minus 2y minus z equals negative 180. Again, I just multiplied everything by -1. I'm going to keep equation 3 as it is. So 4x plus 2y plus 3z, and this equals 280. And again, I have opposite coefficients on my variable y. I have -2 and +2. So when I add the left sides, this is going to cancel, right? So negative 3x plus 4x is going to be x. And then we have negative z plus 3z, which is plus 2z. And this equals negative 180 plus 280 is 100. So let's erase this. And again, we already know from our equation 4 that x is going to be 40. So I'm going to call this equation 5 now. And I'm going to plug a 40 in for x there. So I have 40 plus 2z equals 100. And let me subtract 40 away from each side of the equation. This cancels. And this will become 60. So let me kind of clean this up a little bit. We essentially just have 2z equals 60, divide both sides by 2. And of course, we find that z is equal to 30. Okay? So let me erase all of this now. We don't need any of this information anymore. I'm just going to put over here that x equals 40 and z equals 30. And now we just need to find y. Okay? And that's pretty easy to do. Just plug into any of the original equations, a 40 for x and a 30 for z, and figure out what y is. So it looks like it's pretty easy to work with this second equation, or this middle equation. So 3 times x, 3 times 40, plus 2y plus 1 times z, z is 30, so just plus 30, equals 180. Okay, well 3 times 40 is 120, 120 plus 30 is 150. So let's erase this and put 150. Then if I subtract that away from each side, this cancels. You'll have 2y is equal to 30. Divide both sides by 2, you get y equals 15. Okay, so y equals 15. All right, so let's erase everything and we can state our answer. So let me copy this real quick and let me just paste that here. So we remember that x is the amount in ounces of the corn mixture we're going to use, and that's going to be 40. Okay, so we're going to use 40 ounces of the corn mixture. And then we know that y was the amount of the egg mixture we're going to use. That's going to be 15 ounces. And we know that z is the amount in ounces of the vegetable mixture. That's going to be 30. Okay, so let's write this as a nice little sentence. So we will say that they should use, again, the corn mixture was x and x was 40. So 40 ounces of the corn mixture with, you're going to have, again, 15 ounces. Remember, y was the amount of kind of egg mixture, and we had y equal to 15. So 15 ounces of the egg mixture. And then z was the amount of the vegetable mixture they used, and that was 30. So and 30 ounces of the vegetable mixture. Okay. So they should use 40 ounces of the corn mixture with 15 ounces of the egg mixture and 30 ounces of the vegetable mixture. All right, let's look at a simple interest problem. So James has a total of $200,000 to invest and wants to earn a total of $4,900 in annual simple interest. After meeting with a financial planner, he decides to spread the money into 3 different investments. So James will invest in a REIT, which is a real estate investment trust, which pays 3% annual simple interest, a bond fund, which pays 2.5% annual simple interest, and a savings account, which pays 1.5% annual simple interest. If he invests $80,000 less in the savings account than the sum of the other 2 accounts, how much was invested at each rate? So pretty easy problem overall. Again, when you start these, you want to figure out what you're being asked to find. So we just need to find how much was invested at each rate. Remember, he had a total, if we go back up, of $200,000 that's invested, and he wants to earn this amount right here. So we want to set up kind of 3 variables to represent the 3 unknowns. We need to know how much he's going to invest in the REIT, or again, the real estate investment trust, the bond fund, and then also the savings account. So let's go ahead and let our variables like X, Y, and Z represent those. So X can be the REIT, okay, that's the amount he invests in that. And then we can say Y will be equal to the bond fund, okay, the bond fund. And then Z can be equal to the savings account. Okay, so we need to get 3 equations to solve for this kind of 3 unknowns that we have here. So let me go down and let's think about the first equation. Okay, the first equation is pretty easy. You know that the amount that he invests is $200,000, okay? And he invests this with 3 different kind of investment vehicles. So it must be true that X plus Y plus Z equals 200,000. So that can be my first equation. X plus Y plus Z equals 200,000. Okay, that's an easy one because again, the amount he invests in the REIT, which is X, plus the amount he invests in the bond fund, which is Y, plus the amount he invests in the savings account, which is Z, has to be equal to 200,000 because that's what he puts in to all 3. Now for the next one, we can read the problem and it tells us specifically that he invests $80,000 less in the savings account, okay, than the sum of the other 2 accounts, okay? So the savings account was Z, and the sum of the other 2 accounts were X and Y. So if I sum that, that's X plus Y. So it's 80,000 less than X plus Y. So for equation 2, Z, again, the amount he invests in the savings account is equal to the sum of X plus Y. This is the amount he invests in the other 2. So the REIT and the bond fund minus 80,000, right? Because it's $80,000 less than this amount here. Now for the third equation, we need to think about the interest, okay, the interest. So to do that, let's set up a little table. So what we're going to have is our REIT, we're going to have our bond fund, and we're going to have our savings account. And then we're going to have the amount invested, or you could say the principal. We're going to have our rate, and this is as a decimal, and then we're going to have our interest, okay? Now, we're working with simple interest. It's not compounding, okay? So most of you already know, because we talked about this earlier in the course, the simple interest formula is I, which stands for the amount of simple interest earned, is equal to P, which is the principal, okay, the amount invested, times R, which is the rate as a decimal, times the time. And generally speaking, this is going to be in years, okay, unless they tell you it's in months or something like that. But most of these problems, it's going to be years, okay? Now, in this case, we're talking about on an annual basis, so it's 1 year. So because T would be a 1, you can just drop it out. And you could say that the interest earned, which is this column right here, okay, is going to be equal to the product of these 2. The amount invested, or the principal, multiplied by the rate, okay, as a decimal. Okay, so let's erase this real quick and let's see if we can get this information. So specifically, it tells us the REIT pays 3% annual simple interest, the bond fund pays 2.5% annual simple interest, and the savings account pays 1.5% annual simple interest. So for the rate, for the REIT, it's going to be 3% or 0.03 as a decimal. And then for the bond fund, it's going to be 2.5% or 0.025 as a decimal. And then for the savings account, it's 1.5% or 0.015 as a decimal. Now, for the amount invested, remember, this is unknown. X is used to represent the amount invested in the REIT. Y is used to represent the amount invested in the bond fund. And Z is used to represent the amount invested in the savings account. So again, the product of these 2 would give me the simple interest earned over the course of a year. So 0.03 times X, 0.03 times X is the simple interest earned from the REIT. 0.025 times Y, okay, is the simple interest earned from the bond fund. And 0.015 times Z is the amount of simple interest earned from the savings account. Now, what do we do with this information? How do we make an equation? Well, if you were paying attention to the first part of the problem, it tells us specifically he wants to earn $4,900 in annual simple interest. Now, the $4,900 can only come from these kind of 3 sources. So I know that the interest from the REIT, which is 0.03x, plus the interest from the bond fund, which is 0.025y, plus the interest from the savings account, which is 0.015z, has to be equal to that amount, okay, that $4,900. So let's copy this. This is going to be our third equation. So again, if you don't like working with decimals, you can clear them. For this one, you've got 3 decimal places here and here. So you've got to multiply everything by 1,000, okay, by 1,000. So this guy would move 3 places to the right, so it would be 30x. So it would be 30x. This guy would be 25y. So plus 25y. Then this guy would be 15z. So plus 15z. And then this guy, again, if this is right here, let me kind of scooch this down so we have room. I'm moving everything 3 places to the right. So I put a 0 here, a 0 here, and a 0 here. This would go 1, 2, 3 places to the right. So I would end up with 4,900,000. Okay? So now that we have our 3 equations, we can solve the system and figure out the answer. Now, for equation 2, you really want to set this up into the format of, ax plus by plus cz equals d. Okay, all the variables on one side, the number, the constant on the other. So I can really just drop the parentheses from here. And essentially what I'd have is, if I move each of these over here, I would just subtract them away. I would have negative x minus y plus z. Okay, so negative x minus y plus z is equal to, and it's going to be negative 80,000. Okay, so it's really easy to use elimination to get rid of either x or y from the kind of first 2 equations. So let's just choose to get rid of x. You'll notice that both of these are going to drop out. So it's going to be a nice, easy scenario for us. So for equation 4, what I'm going to do is I'm going to add equation 1 and equation 2 together. So x plus negative x, that's gone. Y plus negative y, that's gone. Z plus z is 2z. And this will be equal to 200,000 minus 80,000 is 120,000. And of course, if we divide both sides by 2, we'd find that z is equal to 60,000. So we already know what z is, right? Or the amount that he invests in the savings account. What about y and x? So we're going to pick another 2 equations. So again, we can do 1 and 3 or 2 and 3. And we're going to eliminate, you can do either x or y. Okay, it doesn't matter. You just eliminate either x or y so that you can plug in for z and figure out what the other one is and then back substitute again. So from 2 and 3, let me just go ahead and eliminate x. So let me scroll down and get some room going. So equation 2, it's already negative, but let me multiply it by 30. So I would have negative 30x minus 30y plus 30z, and this equals, if I took negative 80,000 and multiplied it by 30, negative 8 times 3 is negative 24. And then I have this many zeros, so 1, 2, 3, 4, and then I'd add one more 0. So this would end up being negative 2,400,000. Okay, so then I'm just going to copy equation 3 as it is. So 30x plus 25y plus 15z equals 4,900,000. Okay, so let me scroll down and get some room going. And we know that this is going to go away. Negative 30y plus 25y is going to be negative 5y. And then plus 30z plus 15z is going to be 45z. And this equals, if I take negative 2,400,000 and add that to 4,900,000, I'm going to get 2,500,000. Okay, and we'll call this equation 5. Again, I already know what z is, so what I'm going to do is I'm going to plug in for z here. It's going to plug that in, and I'm going to find out what y is. So I have negative 5y plus 45 times 60,000, okay, is equal to 2,500,000. Okay, so 45 times 60,000 is 2,700,000. So I would have negative 5y plus 2,700,000. Okay, and this equals 2,500,000. Let me scroll down a little bit. So we already know if I subtract 2,700,000 away from each side, this is going to cancel. I'll have negative 5y is equal to 2,500,000 minus 2,700,000 is going to give me negative 200,000. So negative 200,000. If we then divide both sides by negative 5, I'm going to find that y is equal to 40,000. Okay, 40,000. So what's x going to be? Well, if I just plug into this first equation, which is pretty easy to work with, I can easily find out that X is going to be 100,000, right? And you can eyeball that and see 60 plus 40 is 100, right? So it's going to be 100 grand. And then if you had 200 there, well, I'm missing 100, right? That's how I did it in my head. But again, you can plug it in. It doesn't matter. So X plus Y is 40,000 plus you have your Z, which is 60,000. This equals 200,000. And again, you know that this sum here, 40,000 plus 60,000 is 100,000. So this is 100,000 here. And if I subtract 100,000 away from each side, this goes away from here. And over here on the right, it's going to be 100,000. Okay? So we get that X is 100,000, Y is 40,000, Z is 60,000. So that means that he invests 100,000 in the REIT, he invests 40,000 in the bond fund, and then 60,000 in the savings account. All right, so let's write that real quick. And I'm going to make a nice little concise answer and just say that he invests $100,000 in the REIT, or again, the Real Estate Investment Trust. And then he put $40,000 in the bond fund. And he put $60,000 in the savings account. All right, for the last problem, we have that on Monday, Jennifer went to the store and spent a total of $7.45 on 3 one-gallon containers of milk and 2 cartons of eggs. Later that day, her husband Jim stopped at the same store and spent $6.45 on 2 one-gallon containers of milk and 3 cartons of eggs. When Jim got home, he realized his error and decided to only return the milk, as it would expire too quickly for them to consume. How much will Jim receive as a refund? Okay, so this is what we're trying to figure out. How much will Jim receive as a refund? Now, this is given the fact that he's only going to return the milk, okay? He's not returning the eggs. He's just returning the milk. And we don't know the individual prices for anything. We're only told that, Jennifer goes to the store and she spends $7.45 on 3 one-gallon containers of milk and 2 cartons of eggs. And then later on, Jim goes to the same store. Okay, so we're going to assume it's the same price for the milk and the eggs. And he spends $6.45. He only buys 2 one-gallon containers of milk and 3 cartons of eggs. Okay, so we've got to figure this out with a system of equations. The unknowns here are going to be the cost for a 1-gallon container of milk and the cost for 1 carton of eggs. So let's let X be equal to the cost for 1 gallon, okay, and this is a 1-gallon container of milk. And then Y can be the cost for 1 carton of eggs. Okay, so what can we do with this information? Let's go back up. So we know that Jennifer spent $7.45 on 3 one-gallon containers of milk and 2 cartons of eggs. So the way we can model this, since X is the cost of 1 gallon of milk and she bought 3 of them, then 3 times X would be the amount she spent on milk. Then plus, you have the fact that she buys 2 cartons of eggs. Okay, so 2 cartons of eggs. Y is the cost of 1 carton of eggs. So 2 times Y would give me the cost for eggs in that kind of transaction. And again, if I sum these 2 amounts together, I get the amount she spent, which is $7.45. Okay. Again, you can clear the decimal if you want. You can multiply everything by 100. So we could say this is 745 is equal to 300x plus 200y. Not necessary if you're working with a calculator, but I'll just do it because your book would probably do it. Then for equation 2, I'm going to do the same thing with Jim. So if we go back up, so for Jim, he spends $6.45 again on 2 one-gallon containers of milk and 3 cartons of eggs. So we would have that 6.45 or $6.45 is equal to, again, he only bought 2 gallons of milk, so 2x, plus he bought 3 cartons of eggs, so 3y. Again, you can multiply everything by 100 and say this is 645 is equal to 200x plus 300y. Okay, so let's erase this and let's drag this up. So we only have a linear system with 2 variables. So Pretty easy to work with this at this point after we've been dealing with 3. All right, so we can solve this with substitution if we want, or we can solve it with elimination. I think it's probably better to solve it with elimination, although substitution would probably be just as fast, but let's just use elimination. So what I'm going to do is I'm going to eliminate the variable x, and the way I'm going to do that is I'm going to think about the least common multiple between 300 and 200. So that would be 600, right? If I think about 3 and 2, okay, 3 and 2, the least common multiple would be 6. Just because it's 300 and 200, now it would be 600, okay? So what I'm going to do is I'm going to multiply equation 1 by, let's say, negative 2. So 745 times negative 2 would be negative 1,490. And this equals 300 times negative 2 is negative 600. Then, of course, times x. And then 200 times negative 2 would be minus 400, and then times y. Then for this guy right here, I'm going to multiply it by positive 3, okay? So 3 times 645 is going to be 1,935, and this equals 3 times 200 is 600, then times x, then plus 3 times 300 is 900, then times y, okay? So if we sum the left sides together, we're going to get 445, right? So 1,935 plus negative 1,490 would be 445. On the right sides, this would cancel. Negative 400y plus 900y is 500y. So let me erase this. We don't need this anymore. And let me just kind of slide this up. So let me bring this up. Let me divide both sides by 500. So divide by 500. So I can just erase this and say y equals this. Now this is a fraction. If you want to simplify this quickly, here's how I would do it. I would break this up into 5 times 100, okay, because it's easy to divide by 100. 445 divided by 5 would be 89. So if I cancel this with this, I would have 89. Okay, so I have 89 over 100 now. So we know if we divide by 100, just moving my decimal point 2 places to the left. So this would be 89 here. This would go 1, 2 places to the left, so 0.89. Okay, so that's my y. So y is equal to 0.89. So that's the cost of 1 carton of eggs. So apparently where they live, it's super cheap for eggs. Okay, so then now we need to find out x, and of course I could just plug into either equation 1 or 2. So I'm just going to use equation 1. So 745 is equal to 300 times x plus 200 times, you've got your 0.89. Or again, you can do this in fractional form if you want. Remember, this was 89 over 100, okay? So that allows me to just cancel this with this and get a 2. And then 2 times 89 is 178. Okay, so 178. Let me subtract that away from each side of the equation. That will cancel. 745 minus 178 is going to be 567. So this equals 300x. Let me erase this. And we can use a similar trick again. This will help you if you don't have a calculator, right? So this guy right here, if I divide both sides by 300, I can think about 3 times 100, okay? So what's 567 divided by 3? Well, that's going to be 189. So this would be 189, and I'm going to cancel this down here, over 100, right? So let me erase this. So x is 189 over 100, or again, this moves 2 places to the left. So x is equal to 189, move this 1, 2 places to the left. So 1.89 or $1.89. So that's the cost per 1 gallon of milk. So apparently wherever they live, they have really cheap milk and really cheap eggs. Okay, so this does not actually answer our question. Okay, so this is where a lot of students mess up. They say their answer is it's $1.89 for 1 gallon of milk, and it's 89 cents for 1 carton of eggs, and the teacher marks it wrong, and they wonder why. The reason is you have to read the problem, okay? How much will Jim receive as a refund? He only returns the milk, okay? So how much milk did Jim get? Jim got 2 1-gallon containers of milk. Again, the milk is $1.89 a piece. So all I need to do is take the 1.89, again, that was X, that was the cost per 1 gallon of milk, and multiply it by 2. So multiply it by 2. Again, all you have to do is 189 times 2, and then move the decimal point 2 places to the left. So 189 times 2 is 378. So it's 378. Again, move the decimal point 2 places to the left. You get $3.78. So he will get, or he will receive, if you want to say that, $3.78 for his refund. Again, just for the milk. make sure you read these problems because they throw kind of curveballs at you to make sure you're paying attention.